This session is a consortium of various institutions comes together to solve much larger problem. So just to give you a picture, what we are just looking at when we say oil and gas, we have to look at various assets which is distributed in a larger area. The biggest problem comes into that. Your individual assets could be moving parts or non-moving, rotating, non-rotating, or even buried and open. All that is going to be there. So, and your long pipes are going to be monitored and looked at. The health of the individual assets is the biggest issue. In addition, if you see, you need to look at net zero emission, how you can minimize, even as an energy industries, we look at that aspect of it. And energy guzzling and health and safety is at most important at the end, right? So we have a various aspects of it. As a IISc, we have been doing quite a bit of research in terms of advanced sensing solutions and modeling to understand various aspects of it. And we have Accenture and Flutura. They are working on industrial AI and at the top integration of your demand supply with respect to the asset integrity, that you need to look at the holistic optimization aspect of it. And then we have a ProSim which looks at the modeling aspect of various assets and how we can all come together as a single unit to provide a solution which makes feasible for energy industries. Okay, that's the whole agenda of this particular session. First, I'll probably show you some of the work, research and development, which is happening at IISc first. Okay. Okay. See, AI and autonomous system is a key to solve many issues. And when we move, we are now in Industry 5.0, or I would put it like industrial AI, right? So, how industrial AI is going to play a role in looking at various aspects that what we have highlighted. Maybe I'll not just go into all the aspects, but I'll just pick up 3 flavors of it. One is sensor analytics. Sensor analytics is going to play an important role to understand your assets. So I'll just look at from the point of view of how you can just bring in multiple energies that we can just look at, and how we can do optimization to reduce the energy consumption in the building, which we have done, to give you a bigger picture of how IoT and AI ML comes in reducing the energy consumptions. And then I will also talk about how modern, see, many cases you can't approach the assets very close. Some places is an uncertain environment, or it is difficult to operate and human operator to understand what is happening inside. So we can just look at autonomous system, autonomous robotic system, go and look at the health of these assets, how they can help in understanding and predict what is going to happen. So that's the 3 flavors that you wanted to touch upon today. And this particular piece of work was done when I was in Singapore. So one of the questions being asked, being a larger area where you have energy production in one side is happening, and you also need a heating solution or cooling solutions needed for a larger estates, and you have a load demand, everything comes into picture. How you can just combine these systems together to minimize the energy consumption in the larger estate, right? That's a question was asked in front of us. Moment you enable IoT sensors, you have a lot of data, and you need to monitor the assets and assets performance as is one of the key issues. And then we need to look at optimization in multi-scales. The one at the facility level, one at the assets level, and another one that's at the building level, right? And all these you need to look at. Some scales in hours, some scale will be in minutes. So you want to bootstrap suddenly and cooling system for the larger area. It doesn't happen instantaneously. It has its own time constants, right? So you have a multi-level optimization take place here with respect to data-driven information comes into picture. So we made a larger software architecture, what we call smart multi-energy system software architecture, wherein we get the sensors from various locations integrated together. And then we have the analysis comes into picture, and this predictive analysis tell us what's going to happen, which assets is really needed, their health, demand, supply together to minimize the overall energy consumption. And so the test area was the Clean Tech Park, which has about 5 buildings in the estate. and we have a solar panels on the top of this, and then we have a gas turbines to provide the energy required for various companies sitting there. And then we also have a storage there, electrical storage. We have thermal storage too, right? And we have a smart AC DC grid combined there. And then this is what we build on top of it. We brought in SMES command control center, which looks at management of various aspects of it, various level of optimization required, even looking at the energy market demand, and which is 24 hours ahead, what we need to tell them what is my demand required, and forecast in terms of 6 hours for operational level, and integrate in minimizing total 30 to 50% as the objective. So we achieved a 50% reduction in consumption by bringing in optimization multi-level, introducing AI and IoT. The second problem which I wanted to touch upon to give you a flavor, inspections. Large pipelines, some of these are buried, and this when moment I say it runs for 25 kilometers, sometimes even it runs for 50-kilometer distance when from your production to various places. Some are exposed in harsh weather, some are buried, right? To know the status health of these is an important issue, because some carries chemicals, some carries fuels of importance, some carries a gas which is of significant to understand whether there is a leakage and all this, right? And going on these environment, really looking at monitoring as a critical things. We are looking at how we can just superimpose on various status of these at time scales and trying to see and interpret what is happening into that. So what we did is we have a combined multispectral sensors integrated with autonomous drone, which can just go in and real time it can just look at the inspection of it and understand thermal variations, spectral variations to see what type of gas, where it is going, how it is going on that. Okay, I'll just give you a small video for you to understand. One was taken again on a refinery to understand the flame. You see the thermal variation. This is a fused image of multiple spectral data to understand what type of gas coming out, how the flame, how the gases has been burnt, what is left over. We can understand all of this by just looking at the multispectral data. It reveals, you can understand now what emission goes out, how much of gas has been not burnt, right? So all that we can understand here from this solution, right? And on the other hand, if you look at large area of pipes, so we have a multispectral camera again to look at optical image, which doesn't show on one side you see an optical image. It doesn't show anything, the integrity of your pipe looks all right. But moment I just put in the thermal view of that, what's happening, it reveals where the hot spots are happening, right? Hot spots happens because of the stress level that in the pipes is present. The stress levels could be internal corrosion or it could be an external corrosion. All that can be detected in using the multispectral informations there, right? Without physically sending a sensor, we can just looking at external sensors, right? Now, you could ask a question, okay, it's fine if the pipelines are overlaid on the surface. What happens if the pipelines are buried, right? Buried pipelines has an interesting characteristics because when you look at the hyperspectral, the penetration power is limited to certain depth. But we can look at the ground penetrating radars. The radars will just throw in insights about the health of these machines, right? So if I combine this with the physical modeling of the pipe, right, I can understand the stress which is taking place at the individual surface level to identify the surface level degradation in the pipe, right? So this is where the advanced sensing solutions will help you to understand this health status of the individual system. On top, we can just bring in, predictive maintenance aspects of it, right? I have a sequence of images happening over a period of time. It's just think of it as a time machine. I already have the data of typical health of the pipe, and I'm monitoring that, one periodic monitoring of this area. I just ask the fundamental questions to AI here, right? It's not like a conventional way of looking at. We ask a question to AI itself, what do you want to learn? When do you want to learn? How do you want to learn? If you bring in the autonomy inside, it will ask the right question. Is this the right image if I wanted to look at to predict what will happen in 5 years, or this image is not required, it has some anomaly there which I need to ignore. Right? It's a very critical aspect. Data is an issue in when moment we talk about AI. When I say data, right data is important, right? Inference depends on right data. Currently the management also looks at the data and to make a decision. But if the data is not right, your inference will be wrong. So if I can bring an autonomy into the system to ask the right question to build my model, my decision that I just make from the model will be more efficient. Right? So we bring in the concept of a typical student learning, and look at the way the student learns, right? He doesn't really, if you know the subject very well, some of the topic, what I'm mentioning, maybe some of you know very well, it may not be interesting to you. For some, it will be exciting, right? So suddenly I talk about something that, this particular spectrum is good enough to look at the thickness of the pipe. Then if you don't know, you will just excite and then see what is that I'm trying to talk about, right? So that's the characteristics of human learning. So when we can bring in this idea, what we call this metacognitive system, right? It's like reading a storybook. It doesn't excite me the most. What excites me the most is what will be the author's state of mind when he is just trying to look at it, right? So that's the key. So we bring in the concepts of the metacognition inside the AI. So AI asks the questions of what to learn, when to learn, how to learn, right? So we bring in these and add necessary learning aspect into the structure. So when the architecture trying to learn from the data, it rejects the data which is not required to be learned. So what happens at the end is I may use a smaller set of data to really pick up the knowledge. That set is the key data for me, which I can interpret even further, right? So that's the idea we bring in. So we just automated the solution. When we get all these images, we could be able to identify, segment it out, compute the area, so all this can be added in on top of it. What I just wanted to bring in here is the development of sensing solutions which can see deeper. Is more like eye on the sky for you to look at the perspective of various levels. Some could be on not necessarily an imaging, some could be on simple pressure temperature variations which comes up. And on the other hand, you have imaging solutions. We look at the spectral informations of different locations, put together, look at the system as a connected, multiple subsystem as a connected systems, which has a various time scale of operations. This complexity requires a collaborative effort, okay? So maybe at this point of time, I would just like to stop what research activity which could make sense for oil and gas in terms of asset monitoring, prediction, and looking at what maintenance aspect of it as well as asset integrity aspect of it. But various aspects of AI and how industrial AI can change the way that we can understand the data will be addressed by my colleagues from Flutura Accenture. Over to you, Derek.